if you plotted just the radians versus distance, you would get a curve that looks like this. But if you plot 1 over d squared, then you should get a straight line through the origin. And some people that I've seen that have plotted it actually have been getting some quite nice straight lines, which is really good to say that this is completely full of errors, this experiment. Now, I do want you to write down what I've written down at the side about an evaluation, so the evaluation points. Sometimes you can get asked for evaluation points in prelims, so like, how could you improve this experiment? And this one's quite a nice one because it's quite a lot you could improve. So you make sure you keep the same light source. Don't swap your bulb in between. Black out the room would be ideal. Obviously, we couldn't do that. Use a pin source. So our bulb isn't actually a pin source. But basically, what we mean by that is, ideally, you stick a piece of black tape in front of it with a little hole in front of it, so you're only measuring that light that comes straight out of it. And non-reflective surfaces would be good, so you don't get the back shine. So those are just some examples of what you could do. And if you were doing something like, if you were doing the assignment, which I know not this year, but evaluations are really important. If you do go on and do advanced high physics, then you will need to think about things that you could improve in the experiment, or things that you would improve in the experiment and you do improve. So it's really good to show that thought process. Give that up for a second. Okay. Has everybody got that written? Is anyone still writing? Right, so in conclusion, since the graph of irradiance against 1 over d squared is a straight line through the origin, we know that means that irradiance is directly proportional to 1 over d squared. So irradiance is a constant times by 1 over d squared. In other words, you could rearrange that and you could say that I times by d squared is constant. So I1 times d1 squared would be equal to I2 times d2 squared, which would be equal to I3 times d3 squared. The initial irradiance times by the initial distance squared would be the same as another irradiance times another distance squared. And this is an expression of the inverse square law, which states that the irradiance of the illumination is inversely proportional to the square of the distance from the light source. Okay, and that equation there is very important. We're going to go through an example in a second. So feel free to have a read through the example on the next page. Okay, so the intensity of illumination at a distance of 4 meters from a lamp, remember intensity, irradiance, same thing, is 5 times 10 to the minus 3 watts per meter squared. at what distance would the intensity be 8 times 10 to the minus 3 watts per meter squared? So we know now that I1 times D1 squared equals I2 times D2 squared. So initial intensity, initial radiance is 5 times 10 to the minus 3. And the initial distance is 4, so 4 meters squared. We want to know what the distance would be at the second intensity, which is 8 times 10 to the minus 3. So times d2 squared. d2 is what we want to find out. So you rearrange that, d2 squared is going to be 5 times 10 to the minus 3 times 4 squared all over 8 times 10 to the minus 3. And I believe that comes to 10. So d2 squared is 10. So d2 square root of 10, so it's about 3 meters. That's 3.1. It's because it says 4 meters, use the same amount of significant figures. Okay. So there's a note just at the bottom there. Just leave that for a second. But it's basically saying the Inv Sq Law only applies to a point source. A point source is one which irradiates equally in all directions, i.e. the volume that will be irradiated is a sphere. Okay, so basically what that means is like the light bulb is a point source. Okay, so because it irradiates all around. It's not an ideal point source because it doesn't irradiate downwards because we've got the sort of holder for the light bulb, but more or less it irradiates in a sphere around it. Things like lasers don't irradiate in a sphere around them, they just send a beam out in front of them. Okay, so that's what we mean by that. So the volume that will be irradiated is a sphere. The surface area of a sphere can be calculated using 4 pi r squared, i.e. the area that will be irradiated will be proportional to r squared or d squared. So that's why it's that the d squared is because it's related to the area that it is irradiating. Okay. So it radiates a sphere around it, but as it moves further out, it's actually covering more of an area as it gets further and further out. Okay. Everyone got that done? Right, so this is basically the next couple of pages is basically saying that. Okay, so I'll let you guys read that yourselves rather than me go through it, but it's basically talking about the area of a sphere and how with the Inv Sq Law, with a point source, the light hits a sphere around it. Okay, so I'll let you read through yourself and you can ask me any questions at the end. So pages 5 and 6 is just a case of you guys reading through it and asking me any questions that you might come across. Okay?